Okay, now we are going to see formula for general terms. If you are given a sequence, it's easy to predict the cross terms like the fourth, fifth, eighth terms, etc. But if you are told to get 100th term, now it's going to be, for example, if you see that the trend is you add 2, you add 2, you add 2, it's going to be hard for you to add 2 on those terms until when you get the 100th term. So there now, it's going to be a bit heavy. Now there, try to predict a formula or to get a formula that's going to help us get to that term with ease. So that calls us for getting the general formula that can get any term or the nth term of the sequence, as you are going to see here. So our task is identifying the nth term. So in groups of 5, find the formula used to identify the nth term of the sequence, 12th term of the sequence below. So these are the sequences we have. These are the sequences we have. I'm going to start with this, then we shall see these other 2. So here you can see from here to here what happens. You can see the trend of the sequence. What happens? We add to 2. So from here up to here, there is plus 2. From here up to here, there is plus 2. Then from here up to here, there is plus 2. So there, you can start our first term is going to be 5. So our second term rate is going to be, I think it's 67. Then our third term rate is going to be 9. Then our fourth term is going to be 11. Now, basing on 5, you see that this is the same as, you see to get 7, we got 5 plus 2. 5 plus 2, we get this. Then basing on 5, we got 5 plus 2 plus 2, then plus 2 to get a 9. Then basing on 5, we got 5 plus 2 plus 2 plus 2. I think you can see that trend. So now, the whole of this one is giving us just 5. This one is giving us 5 plus 2 times 1. I think this is the same as 2 times 1. So this one is going to be 5 plus 2 times, these are 2 times. So 2 times 2. I think you can able see that. And then this one is the same as 5 plus 2 times 3. So instead of multiplying 3 2 times. Hope you can able see that closely. So, or if you don't want that, then you first get this as 4, which is the same as 2 times 2. This is 6, 2 times 3. So you are getting 3 2 times. We'll be having this. Hope you are clear there. Okay, now from there, we can even predict the 50th term. Now, I want you to note this. I want you to note this with the term we are having. You note this, and then the term we are having. You also note this, and the term we are having. So what do you think is the relationship between this? You see that this 2 is constant throughout. So what's the relationship between this and the term? This and the term. Yes, the number is always less by 1. So this number is less by 1. If you have the third term, we are getting 2 times 3 minus 1, which is 2. Then if we have the fourth term, this will be 2 times 3. So now, can we predict when we have the 50th term? It's going to be the 50th term. Can we predict we shall get 5, then plus 2 times. What's going to happen here? So we shall get 5 minus 1, which will be 5 plus 2 times 4. Are you there? So it means that now, to get the 50th term, so you see that when we add here a 2, I think we can see we are going to get 13. When we simplify here, I think it's that we are going to get 18. We shall be adding 8 plus 5, which is 13. Are we there? So can we get the 70th term? Now let us get to the 8th term. The 8th term is going to be now the first then plus 2 times, because 2 is what we are adding on it. So 2 times, now we get 8 minus 1, which will be 5 plus 2 times what? 7. So now, can we get the nth term now? The nth term, still we shall get 5, then plus 2 times the term itself, which is n, then minus 1. So what does it mean? It means that now when we simplify, this will be 5 plus 2 into n minus 1, which is 5 plus 2n minus 2. When we get this and this, we shall get 5 minus 2 plus 2n, which is going to give us 2n plus 3, and this is going to be our nth term. So this is our nth term, as simple as that. So for any term you want, you use this formula. Can you try? Okay, you try. So this n is the nth term. You try. When n is 1, we have the first term. When you put here n is 1, we get the first term. So therefore we can generalize with the formula here, so that we get the nth term. Therefore, we can call it u. So our nth term, therefore, we call it u1, the nth term of the sequence. We can call it un. Therefore, our nth term, un, is going to be 2n plus 3. Formula for getting the nth term. Formula for nth term. So you try it and see. When we want to get the first term, it means that n is 1. When n is 1, when you put here 1, so we have 1 times 2, which is 2, plus 3, which is 5. So if you want to get the second term, n is 2. So we have now 2 times 2, which is 4, plus 3, which is 7. I see that. Okay, let's try to get the fourth term. The fourth term we shall get, now it will be n will be 4. So we get now 4 times 2, 8. 8 plus 3, get 11. Is it the fourth term? 1, 2, 3, 4. It's the fourth term. So you see? Okay, anyway, that's one the part B. So to get part B, all we are going to do is, to get part B, they want us to get the 12th term. So the 12th term means that our n is 12. So our u12 is going to be 2 times 12, then plus 3, which will give us, this is 24, plus 3, which will give us 27. That's the 12th term. So then they want us to get the 21st term. 21st term. 21st term, so that now from there, our n is 21. Can you put it in the formula? So we have now our u21 as 2 times 21, then plus, we are putting in this formula here. Now our n is 21 times 3. Plus 3. This would be 42 plus 3, which would be 45. So that's how we use the formula. So that's how we generate the formula. So the idea was, this common thing here is always what we multiply through. And then this works if we are adding. So here is that we are adding just, even if you are subtracting, the rule is going to apply. You will see what happens there. You see, you'll be subtracting, because we are not here. But anyway, that's how we handle that. So you have the 12th term. I think you see that you can, even you can get 100th term with ease. Hope you can see that. Now, let us come to this one. This one is a bit different. I want you to be careful. So this one, you see that from here to here, what happens? We are adding 2. Okay? Then from here up to here, when we add it 2, the trend should be the same. Do we get, on 3 when we add 2, do we get 9? No. We are multiplying by 3. So here we say times 3, then here and here times 3, then here and here times 3. Okay, so our first term is going to be 1, not so. Then our second is going to be 3. Then our third is 9. Then our fourth is what? Is 27. So what do you see? This is the same as now based on 1 times 3. So this would be 1 times 3 times 3. 1 times 3 times 3, we get this. Then this would be 1 times 3 times 3. So times 3 times 3 times 3. Not so. That's when we get your first term. Now you can every see this is the same as 1 times 3. This would be 1 times 9. This would be 1 times 27. So what do you note? So you note that this is going to be 1 times 3 power 1. Right? This is the same as 1 times 3 power 2. It's the same as 1 times 3 power 3. I think you note. So this 1 here, for it is the same as 1 times 3 power 0. Hope you get that. So now, if this was 2, you apply the same method. So as long as it's the first term here, we get the first term times. So now you note the relationship. It's that this power, you note this power here, and then the term we have. You note this power, and then the term we have here. You also note this power, and then the term we have there. What do you see? When you have the second term, the power is 1. So this one is constant. What we are multiplying through with, so you are multiplying through by 3. Hope you can see that. So when you have the third term, the power, you get what you multiply through by, then power 2, then you multiply with the first term. Then you get the fourth, you get 1 times 3. So if this was 2, then this would be 2 times 3, if 3 was the common term. Then 2 times 9. So this would be 2 times 3 power 2. This would be 2 times 3 power 3. So you see the fourth goes with the third. So it means that now, if this is 4, this is 3, what do they do? They subtract off 1. So if I have the fourth term, I reduce it by 1 to get the power, you are going to power what we multiply through. So if I have the 53, let me see. The 53 will be the first then times 3, then 5 minus 1, which will be 1 times 3 power 4. Hope you see this. So if I have the 63, okay, let me go to the 9th. Let me skip now, I go to the 9th. It will be 1 times 3, then 9 minus 1. Because that's a term we've been seeing, which will be 1 times 3 power 8. So if I want the nth term now, it will be 1 times 3, the term, then you subtract off 1. Hope you can see that. So this will give us 1 times 3 power n minus 1. Hope you can see that. So there, our nth term, U1, is going to be 1 times 3 power n minus 1. I'm maintaining this one because in some questions this is not going to be 1. It can be 3, it can be 4, it can be 5, so that we get 5 times now the formula. So this is the formula we use to get the nth term. So you try, when n is 1, we have 1 minus 1. So n is 1, that's the first term. So 1 minus 1 is 0. Any number to power 0 is 1. 1 times 1 is 1, which is our first term. When n is 2, so that's the second term, we have 2 minus 1, which will be 1. So 1 times 3, we have 3. When n is 3, the third term, we have to use 3. So you have now where there is n, we have 3 minus 1, 2. 3 power 2, 9. 9 times 1, 9. Okay? So that's how we generate that. Anyway, they want us to get the 12th term. So part B, 12th term. 12th term, it means that our end is 12. So our U12 is going to be 1 times 3 power 12 minus 1, and then you get the answer there. Then to get our 21st term, is that our n is 21. So we shall get our U21 as 1 times 3. 3 is what we multiply. If we have been multiplying with 4, then this will be 4. If we've been multiplying by 3, then this will be 3. You get that? Okay. So this will be now 21 minus 1. Then you get this answer. It will be now 1 times 3 power 20. Then you put it on the calculator and get your answer there. So that's how what happens if we have a product. Now, what happens if we have the difference here? So you see that from here up to here, they are subtracting 4. From here up to here, subtracting 4. They are subtracting 4. Are we there? So now it's our first term is going to be 20. Then our second term, using now the 20 from here, we shall get this 20 minus 4, then minus 4 to get the second term. Hope you can able see that. Then to get the third term, we shall get now the first 20. How many times we are multiplying to get the second term? The second term we just subtracting once. The second term we get this minus this, we shall be having the second. Then the third, we get 20. We must subtract this. Then we subtract this. So minus 4, minus 4. I think you can see the trend now. So from there, you can set our first term, it is 20. Then our second term is going to be now, I hope you can see, it's going to be 20, then minus. This is going to be 2 times, this is going to be 2 times, now it's 4. It's going to be 4 times 1. So our third term is going to be 20 minus 4 times 2. I think now you see the trade. 4 is what has been common. Now whenever we are adding or subtracting, we add. Whenever we are multiplying, we also multiply. So I think you can see the trade. Third, 2. Second, so meaning from there, you can even reduce to the fourth. The fourth is going to be the first, then minus 4. What you subtract, then times. This is 4, then this is 9. So now our anything is going to be 20 minus 4, then times anything is subtract 1 and minus 1. Then when you simplify that, you see we shall be having this as negative 4, positive, this and this will get a positive. We'll be having 24, then minus 4, and now this is the formula for that. So therefore, from there, you can see that our UN is going to be 24 minus 4 into 1. Then you can get other terms. So try. When n is 1, we have the first term. So 1, we have 1 times 4, we have 4 minus 24, we get 20. When n is 2, we have 2 times 8, 2 times 4, which will be 8. So 24 minus 8, we get 16. As simple as that. So that's how we get the nth term. Now we are going to go to page 93 and then we generate those things there. So that's how we handle this one is there. I wish you well.